Greetings to all learners doing technical mathematics in grade 12 specifically, but grade 11s can also listen partly and watch partly. But when we go to three-dimensional figures, then that one is for grade 12. This lesson also accommodates learners who are doing mathematics. Remember, we are talking about solution of triangles, but we are going to extend it and talk about three-dimensional figures as well. In our previous lessons, we talked about right-angled triangles and non-right-angled triangles, and we talked about sine rule, area rule, and cosine rule, etc. Yes, of course, we are back with lesson 3, having done lesson 1 and lesson number 2. The presentation is done by Mr. Njomeni. Now, as I said earlier, we are recapping. We looked at two main types of triangles, right-angled triangles, non-right-angled triangles, where we said right-angled triangle, there will be that sign, or there will be an indication that a certain angle is 90 degrees in that particular right-angled triangle. If that is not indicated, then a triangle is non-right-angled triangle. So no angle is 90 degrees, no angle is 90 degrees. Then it's a non-right-angled triangle. It's a non-right-angled triangle, right? Then now, under right-angled triangles, of course, we talked about Pythagoras theorem, where we apply Pythagoras theorem as well as the definitions of trigonometric ratios. But once again, I'm emphasizing this again, keep in mind your Euclidean geometry, especially the sum of angles of a triangle that add up to 180 degrees. Always keep that one in mind because it's used throughout any topic that deals with triangles for that matter. But we're going to use it a lot when we are solving problems here in trigonometry, right? Then, now, another thing that we talked about was obviously non-right-angled triangles, which was our last lesson, where we said then you need to apply sine rule, you need to apply cosine rule, you need to apply area rule to solve that particular triangle. With area, I will just emphasize that in the area, you don't just use the area unless it's either the area was given or you are asked to calculate the area. So you don't use the area if the word area is not there. There was no question about the area or the area was not given. So the area must be given or there must be a question which says determine the area. So you must see or hear the word area, then you use area rule. Then with sine rule, we obviously emphasized that you must know two sides and one angle which is opposite to one of the given sides, or two angles and any side. With cosine rule, we said you need to know three angles, then you can calculate, three sides, then you can calculate any angle. Or you need to know two sides and an angle formed by these two sides called an included angle. Let me repeat, you use sine rule when you are given two sides and one angle which is opposite to one of the given sides, or two angles and any side. Then cosine rule, you use it when you are given all the three sides and you want to calculate any angle, or when you are given two sides and an included angle, that is the angle which is formed by the two given sides, right? So those are some of the things we talked about there. So in summary, these are the rules or the formulae for these three. So for the sine rule, we said is small letter a over sine capital letter A, small letter b over sine capital letter B, small letter c over sine capital letter C in triangle ABC. In other words, it is the length of the side divided by sine of the angle opposite that side is equal to length of the side divided by sine angle opposite that particular side. Or it can be the other way around. That is, you start with sine of an angle divided by the side opposite that angle is equal to sine of another angle divided by a side opposite to the angle that we talked about there. That is the sine rule. Then cosine rule In triangle ABC, you start it as if you are writing Pythagoras theorem. Remember, if you start with A, then the angle will be A. If you start with B, then the angle will be B. If you start with C, then the angle will be C. So in triangle ABC, you have A. What are you left with? B and C. So it's A squared is equal to B squared plus C squared, and then minus 2BC cos A, because the subject of the formula was A. B squared is equal to A squared plus C squared minus 2BC cos B, because the subject of the formula was B. C squared is equal to A squared plus B squared minus 2BC cos C, because the subject of the formula was C, right? Then last but not least, the area rule in triangle ABC. You remember it's A, B, C. So all the three letters must appear. So if you want to use angle C, then you must make sure that you use the other two sides, which is A and B. You want to use angle C, so it will be half AB. Remember, A, B, and C must appear as letters of alphabets. One of the letters of alphabets will be the angle, two of them will be sides, right? So if you want to use B, obviously it will be half AC. If you want to use A, it will be half BC. So it's half AB sine C, half AC sine B, or half BC sine A, depending on what is it that is given. Depending on what is it that is given. Now, this is very important that you understand all the rules that are there in trigonometry, as well as understand when do you use each rule. Of course, I indicated that for sine rule, you must be given two sides and any of the angles opposite to what you are given. That side, you are given that side, then you must be given maybe that angle or that angle, or you must be given two angles and any side, just because if you are given two angles, then you know the third angle as well. You know the third angle, so you can be given any side there. That's what is very important. Then for cosine rule, we said you obviously have to be given all the three sides. You have to be given all the three sides, or you have to be given two sides, and an angle formed by these two sides. That is called included angle. And for area rule, I always say just look for the word area. It's either you are asked to calculate the area, or you are given the area and you are asked to calculate one of the sides or one of the angles. Then you use the area rule, right? Now, that was just going through what we did, which is obviously going to assist us going forward. Remember, in mathematics, all the basics that you do, even in lower grades, even in previous lessons, they form part of solving the problems to come, or revising anything that is to come in a particular topic. So today, I want us to talk about, or to look at, angles of elevations and angles of depression, and how to solve problems in two dimension as well as 3 dimension. All right, that's what I want us to do right now. Now let's go for it, and let's start with angle of elevation and angle of depression. Angle of elevation as well as angle of depression. Now, to solve problems involving angles of elevation and depression, we need to know the horizontal line. So the horizontal line is like our line of reference. Our line of reference is usually called the observer's original eye level, which is where you are looking at. You just take a horizontal line at your level of the eye if you are to observe anything, as well as the non-horizontal line. So we focus on horizontal line. Where is the horizontal line? It's like our line of reference, the horizontal line, and then now we look at the non-horizontal line, because now we'll be looking at the angle formed by the horizontal line, which is the observer's original eye level, as well as the non-horizontal line, which is observer's lowered or raised eye level, right? Very important. Now let's start with the angle of elevation. Let's start with the angle of elevation. We are going to take this as the point where the eye, that is the observer's eye is. The observer's eye is here. And this is horizontal. This is the horizontal. If that is the horizontal, then now the angle that is above, the angle that is above that observer's eye or the horizontal eye, is, or rather horizontal line there, will be called the angle of elevation. Elevate, that is move up or take it up, elevate. So it means it is angle that will be above the horizontal line, that is angle of elevation. All right. Now when you look at the angle of depression, now you will have an observer's eye somewhere there, and then you have your horizontal line. So you are having a horizontal line. If now what you are looking for is below the horizontal line, which is at eye level, is below the horizontal line at eye level, then that angle is called the angle of depression. Angle of depression. So that's the difference between the two. The reason why this is very important is because in most of the questions you will just be told that the angle of elevation is that. Now you need to understand, once they say angle of elevation, it means it is an angle formed by a horizontal line as well as the line above that horizontal line. If it's the angle of depression, it is the angle formed by the horizontal line as well as the line which is below that horizontal line. So elevation, angle above, depression, angle below. That is very important, right? So there is just to emphasize what I've just indicated. If the end point is above the starting point, then we have an angle of elevation. So the keyword here is above horizontal line or above the starting point. While on the other hand, if the end point is above, or rather is below the starting point, then we have an angle of depression. If the end point is below, which is what you are looking at, it is below that horizontal line, then that angle is called angle of depression. So it's called angle of elevation if it is above. It's called angle of depression if it is below. I hope you understand that, Mfundi. It's very important for you to understand that. That is part of the language that we use. So you must understand the language that is used in mathematics and technical mathematics. It is very important because it is the one which guides you to solve problems. Right. So I want us to do an example about this angle of elevation as well as angle of depression. We're just going to take one example. Of course, it's the keywords that are very important here. So, for instance, let's take this example. A man 2 meters tall stands on horizontal ground 30 meters from a tree. That means this man is 30 meters away from the tree. Now, the angle of elevation of the top of the tree from his eye is 23 degrees. Right? Estimate the height of the tree. Now you must go to the diagram and read what you are reading together with the diagram. Now they say a man who is 2 meters tall. 2 meters tall is very important. So go to the diagram. There is 2 meters. 2 meters. 2 meters. Right? On a horizontal ground, 30 meters from the tree. 30 meters from the tree. 30 meters. It means now this is 30 meters. The distance from the tree to the man is 30 meters, which is obviously also the same as that one, the 30 meters. And then the angle of elevation, which means now this man is going to look above the horizontal line, above that horizontal line. So that angle is 23. So the angle is 23. All right. Estimate the height of the tree correct to 1 decimal place. 1 decimal place. Very important as your final answer. 1 decimal place. Right. Now there is the diagram which is drawn. Now usually the diagrams are drawn so that you can be able to see what is happening there. Note that the line down there where the feet of the man they are at the same level as the root of the tree or whatever, where the stem and the root start or meet, or I'll call it meeting there. So it's horizontal. So take note that this man is not looking at the level of the ground, is already above 2 meters high. That is why now the diagram must have something like this quadrilateral, which represents the man as well as the height of a man. And then from the horizontal, which is at the level of the eye of the man, then there starts now this triangle. Now take note that this angle will be 90 degrees. That is the angle between the horizontal and the vertical will obviously be 90 degrees, which is very important for you to understand. Right. Then now, it means now you go back now to right-angled triangles. What did we say about right-angled triangles? Now you've got this triangle with angle 23 degrees and the adjacent side is 30 meters. Adjacent side is 30 meters. So, and you are looking for the height. Now the height is opposite and this side is adjacent. So remember, the hypotenuse is always the longest side of a right angled triangle and is always opposite to the angle 90 degrees. So now in this case, you are to calculate the opposite side and you are given the adjacent side. You are to calculate the opposite side, you are given the adjacent side. Now remember, we talked about SOHCAHTOA, or any other way you understand the definitions of trigonometric ratios is very important. Now you see that you want to calculate the opposite, you have the adjacent, so it means you are going to use that one, which means you are going to use tan. Then you say tan 23 is equal to, remember now that the height of a tree, this should have gone down like that one, right? This should have been going down like that one, so that you can see that the total height is that one, and therefore this one, the height of this side, that is this side only, it has to be height minus the height of a man, which is minus 2. That is why now you will say tan 23 is h minus 2 over 30, and then you make h minus 2 the subject of the formula. So h minus 2, you take this one is over 1 obviously, then you take that 30 over to that side, and then that one multiplies that one, and then you will have h minus 2 is equal to 30 tan 23 degrees over h, and then it's 30 tan 23 degrees, and then you make h the subject of the formula rather. So h is 2 plus 30 tan 23 degrees, which is 14.7. Remember, you were asked to round to 1 decimal digit, so it is going to be 14.7 meters. That is now the height of that particular tree. All right. So it is very important to understand that. That was just one example in trying to explain or to further emphasize the importance of understanding angle of elevation as well as angle of depression. But we're still using trigonometry, so it means we're still using triangles. So we determine whether our triangle is right angled triangle. If yes, use SOHCAHTOA. If no, use sine rule or cosine rule or tan or excuse me, area rule. I almost said tan rule. There's no tan rule. Sine rule, cosine rule, as well as area rule. So what we must do now is look at now 3-dimension, right? Right. Now let's look now at solving problems in 2-dimension and 3-dimension using trigonometry. Now you'll notice something now, that there I have written only grade 12, which means now this part is only for grade 12. So in other words, grade 11, you don't have to worry yourself about 3D so far. Grade 12, both mathematics as well as technical mathematics, they talk about 3-dimensional figures. All right. So basically, to solve problems in 2 or 3 dimensions, you need to do the following. 1, you need to interpret the given diagram or sketches. I always say do that together with the statement which was written above the diagram. Remember, the first thing is the statement followed by a diagram. Sometimes there are pictures if the problem is from technical field or is realistic, and then after you have done that, after that there will be questions now. So it's the statement above, followed by a diagram which explains or which actually illustrates what was explained in the statement above, and then there are questions that follow. So the first thing that you must do, you must interpret the given diagram. Read the statement and check if what is in the statement is there in the diagram. If it's not there, write it down. If there is a length that is given, which is not in the diagram, write it down. And then the second thing you need to do, you need to identify the triangles you need to work in. Identify the triangles you need to work in. Then the third thing that you need to do after identifying the triangles, you need to decide which trigonometric ratio or rules you are going to use to find necessary information. In other words, if it is a right-angled triangle, then think of SOHCAHTOA, think of Pythagoras theorem. Alright? Like number 4 there states, use Pythagoras theorem if it's a right-angled triangle, and you also use definitions of trigonometric ratios, your SOHCAHTOA or any other method that you understand your definitions with. Then lastly, you must always keep in mind that the use of Euclidean geometry, axioms as well as theorems is also useful when necessary. So in other words, if for instance there is a triangle with 2 angles, then you must understand that the third angle you know. Or if there is a triangle that is given to be isosceles, then you must know what are the properties of isosceles triangle, and so on and so on. It is very important for you to understand that. Now, we'll need to do an example so that we see how then do we apply this, or how then do we solve a problem in 3 dimension to be specific. Remember, we've been doing 2 dimension. Now I'm deciding to take an example from 3 dimensions, or a 3-dimensional figure, which we are going to solve using trigonometry as well as parts of Euclidean geometry, especially the sum of angles of a triangle. That is where necessary. Now, let's look at the question, right? Now, in this case, I've decided to put the diagram on the right-hand side. So it's alongside, it's not below. So in the diagram alongside, in this case, which is usually a diagram and a picture below, especially in technical mathematics, there's usually a picture if the problem is realistic. So we're having a story here. AB is a vertical tower. Where is AB? There is AB. C and D are points on the same horizontal plane as B. So C, D, and B are on the horizontal plane, on the same plane. It's like on the ground. Everything is on the ground, and the ground is level, so to speak. All right. So the foot of the, which is the foot of the tower, AB is 30 meters. That is, that tower now is 30 meters. And the angle of elevation there, that angle of elevation is coming. So remember that 30 meters, you have noted it there is 30 meters is from the statement, is also there in the diagram. Now they say the angle of elevation of A, which is measured from D. Now, where is D? That's where we are going to be. Our eye is going to be. There is D. So the angle of elevation from here is 40 degrees. That is to A. So which means this angle is angle A. It's 40 degrees. Is the angle of elevation. Angle ACD is 35. Angle ACD, which means the whole angle there. That is the angle in triangle ADC or ACD. It is 35. It is 35, right? And then what else do they say? Angle ADC is 100 degrees. ADC is 100 degrees, which means this angle is 100 degrees. All right? So it's 100 degrees. Now the question is, calculate the distance between C and D, which means you are looking for this distance. This distance. You are looking for this distance between C and D. You want to find that distance. And that distance, as you can see, which triangles does it belong? I'm not going to talk about now. And then the last one, determine the area of triangle ADC. Again, triangle ADC. Area of triangle ADC. So questions may be asked in another triangle. only to find out that a lot of information is found in other triangles, which is why it is very important to be able to identify triangles that are there so that we can see which triangle is having more information that I can find the other sides or the other angles from. Then you will take it from there. So judging from the last question, my focus is on triangle ADC, which means in triangle ADC so far, I know two angles, but I don't know any side. So it means it's gonna give me a problem now if that is the case. I only know two angles. I don't know the third angle. Or in fact, I can calculate the third angle, but I don't want to. I'm not interested yet because that's not what is asked. The question is, let's find the distance between the points C and D, which is that distance. So I'm looking for the side. But remember, if I'm looking for that side, it means I will need at least to know another side, which unfortunately I don't know. I can't calculate any side if I only know angles. I must know at least one side. But in this case, I don't know any side. Now, how do I find the other side? Especially, it's either I find angle AC or angle BC, depending which triangle is having more information. But when I look at it, it looks like triangle ABD will have more information. But let's just separate. Maybe let's look at the triangles that are there, and maybe just to break it down a bit and look at the triangles that are there. As I said, you must identify the triangles that are there. So you will see that there is triangle ABC. I'm going to go back and front so that you can see. I've got triangle ABC. What do I know about triangle ABC? The only thing that I know about triangle ABC is that this is 30. That's the only thing that I know. So it has got only one thing that I know, right? It is 30. And then the other triangle that I know is triangle ABD. Triangle ABD. Now let me go to triangle ABD. Triangle ABD. What do I know about triangle ABD? I know this 30 as well as 40 degrees. Now there is a second thing that I know then about that one. So I know that this is 30 as well as 40 degrees, which is already written. All right. So I know two things at least there. All right. Then what other triangles am I given? Triangle BDC. The one which is horizontal on the horizontal plane. Triangle BDC. What do I know about that triangle? I know nothing about that triangle. Right? It's a horizontal one. So which means there is nothing that is given. Then the other triangle will be triangle now. Triangle ADC. Triangle ADC. Triangle ADC. Triangle ADC. In triangle ADC, I know two things. I know that that angle is 35 degrees. I know the angle is 35 degrees and the other one is 100 degrees. Those are the two things that I know. Remember, I'm looking for this side. I'm looking for DC. So it means I can't find DC without finding at least one of the sides. Now the question is, how do I find one of the sides, right? How do I find one of the sides? I will go to triangle ABD. Why? Because triangle ABD is having two things that at least I need. Remember that one, I only have one thing. I only know one thing. This one, I know two things. That one, I know nothing. This one, I know two things, but I want DC. But before that, I can see that that one now may help me because I know a side and an angle. And remember, this is a right angled triangle. So it means I can simply use trigonometric ratios. I can simply use so, ka, toya. Any of those. So, ka, toya. So I must decide which one am I going to use. Which one is going to suit me so that at the end of the day, I solve my problem ultimately. So if I look a bit forward, I will note something that in this triangle ABD, and I'm interested in triangle ADC, so I can find the angle AD. Angle AD. So if I once again go back, I can find angle AD. So which one is given is angle AB. Now 240. What is 30 to 40? 30 is opposite. 30 is opposite. And the side that I'm looking for is hypotenuse. Is hypotenuse. So in SOHCAHTOA, which one do I use? I use sine. yeah. So sine, I'm gonna use sine. So that is why now you see I have used sine there. So that is why you see I have used sine. I said now sine 40 degrees because now my focus is on this triangle. My focus is on this triangle, so I'm using sine of this angle, which is sine 40 degrees, is equal to opposite, which is 30, over hypotenuse, which is 80, the one that I'm looking for. Now remember, now this one is divided by 1, so I can just multiply. This one goes there, that one comes there. So 80 will be 30 divided by sine 40, and then the answer will be approximately equal to 46.67. That is 80 now. 80, 40, 46.67, 67 meters. 67 meters, right? So once I find that, then I can go straight now to my triangle ADB. I can now go straight to my triangle ADC, that triangle. So I can go now to my triangle. There is my triangle now that I'm going to be going to. And then when I go to that triangle, then I now have three things that I wanted. I have this angle as well as this angle, and then I've got a side opposite to one of the given angles. That gives me an indication that I'm going to be using sine. Which side am I looking for? I'm looking for DC. Right? I'm looking for DC. But remember, if I know that this is 100 and that is 35, now what is 180 degrees? Angles of a triangle is 180 degrees minus 100 degrees minus 35 degrees. 35 degrees. I now want the third side, rather the third angle of a triangle. So the answer will be equal to, that will be angle A in that triangle. That will be angle A in that triangle. It will be 180 minus 100 minus 35, and the answer will be 45 degrees. The answer will be 45 degrees, right? So that angle there is now 45 degrees. Is now 45 degrees, right? So in triangle ADC, which is the angle that I'm interested in, so DC will now be able to calculate DC. I will say DC, which is this side, divided by sine of an angle opposite to DC, which is that angle. So DC over sine 45, there is 45. There is 45, that is the angle opposite to DC, is equal to AD, and AD I've just calculated now as 46.67. I should have just substituted by 46.67. 46.67 is the value of AD. And then I just make DC the subject of the formula by taking this sine 45 to multiply there. So it's DC is equal to 46.67 multiplied by sine 45 divided by sine 35 degrees. And the correct answer will be 57.53. When you press the calculator, you will get 57.53, right? Then the second question was for you to calculate the area of triangle ADC. Area of triangle ADC. So remember, there are many ways of calculating the area of triangle ADC. So which means you can still use this side, but if you don't want to calculate that side, obviously you will have to avoid that. So which means you'll have to use this side as well as that side. Obviously, now the included angle will be this one, which is going to be 100 degrees. So I'm going to say now is half of this side multiplied by this side, and then so is half AD multiplied by DC, and then sine is 100, which is the included angle. So AD, DC, and sine 100, and then I simply substitute half angle AD, side AD, I've just calculated it to be 46.67. So it's 46.67 multiplied by the side that I calculated next, which is DC, which is 57.53 multiplied by sine 100, and the correct answer when I press my calculator will be 1342.46 square meters. So as you can see, that is not difficult to work with three-dimensional figures. You must break it down into small triangles, and see which triangle are you talking about and what is given in that triangle. What is it that is needed? Where can you calculate? Which triangle is having more information that I can start with? If it's a right-angled triangle, I use SOHCAHTOA. If it's non-right-angled triangle, then I use sine rule or cosine rule or area rule if the area is given. But remember, we use the area if the question asked you to calculate the area or if the area was given, right? So I want to summarize this whole lesson by just saying, you may also use the following. Ask yourself these questions. Ask yourself these questions. What is it that is being asked? What am I asked to find? If you are asked to find the side, what is it that you know? You can either know two sides and an included angle, then in that case you use cosine rule. Or you are to calculate the side still, but now you know, or you can work out all three angles and you have one side. So you have one side and all three angles or any two angles, then you must use sine rule. If you are to calculate the angle, right, what do you know? If you are to calculate the angle and you know two sides and one angle, two sides and one angle, then it means obviously if you know two sides and one angle, that angle must be opposite to one of the given sides. Then you still use the sine rule. But if you know all the three sides, you know just sides, then you use the cosine rule. So that's basically what you can ask yourself, how you can actually summarize the whole thing, right? That brings us to the end of our lesson for today, which was lesson 3 of trigonometry. So in our next lesson, we shall be looking at solving problems in 2-dimension and 3-dimension using knowledge of solving triangles and taking questions from previous year's question papers, as well as we are going to revise more trigonometric questions or solve more questions now that do not necessarily involve triangles. On that note, thank you very much. I hope that you have learned even in this lesson. Remember, it is always good to know that practice makes perfect. Practice makes perfect. So you need to practice, practice, and practice. So you can take the questions that we have done already, start with them because you've got answers to them. Then go to the new questions. Always test your answers and make sure that they make sense, and make sure that you use your calculator effectively, because calculating, being able to do all the steps and then you are not able to use a calculator is a problem. Thank you very much, and I hope we have learned a lot. Bye for now. See you next time.